Obviously, I had so much fun recording that last video that I went and procrastinated for 4 days. But we're not done talking about loops. So you'd be forgiven if you looked at those first few videos about loops, the ones you probably just watched, but I recorded 4 days ago, and maybe you're a bit overwhelmed. I've mentioned this course has that kind of learning curve. There's a lot of new terminology and syntax and techniques that get thrown at you. We, of course, will spend lots of time going over that in labs and on the Thursdays. But there's one thing left in our sort of introduction to loops, and it's this subject that tends to terrify people about loops the most. What's interesting about it is I'm not going to introduce any new techniques. I'm not going to introduce any new syntax. It's only going to use stuff you've already seen. It's the strange way that it gets used that throws people off. And what's interesting from my point of view about this is when I first learned how to program, this bothered me too. But looking back, there is a sort of sublime elegance to this. What we're going to end up seeing about the way that code works, not even about loops, but about the way that code works, is actually sort of beautiful. But we'll start with a sort of appetizer. So this appetizer, this exercise that I have pulled up here, is not the hard part. And we're actually going to go over this again in a Thursday at some point. But the idea is just to write a loop to put our brains in the right place. So what I want to do is I want to write a program that prints out these 10 multiples of 6, starting at 6 times 1 and ending at 6 times 10, all of them on the same line. But as we know, because we can keep testing as we go, we could begin by trying to write a program that can do some of that stuff and then fix any issues, clean up any problems we encounter along the way. So I think what I'm going to start with is, let's see if we can write a loop that prints out, why don't we just count to 10? So 6 times 1, 6 times 2, 6 times 3. Let's just write a loop that counts to 10, and we'll start there. So I'm going to use, it points out I should use both for and while loops. I think that today I will use I'm going to use a while loop. So I'm going to have a counter. It's going to start at 1. And I'm going to, let's see, well, the counter is less than or equal to 10. And I want to print out the numbers 1 through 10, just to prove that I can do that so that I can work from there. So I'll say printf, and I'm just going to print the number out on a line by itself. Print out %d, and then I print out the value of the counter. And I remember, I was actually about to forget this, but I remember I should add my incrementation condition. Counter equals counter plus 1. And I could say, or I could write counter plus plus, or I could write counter plus equals 1. I guess I better put this in quotes too. So this is a loop that counts to 10. It doesn't do what I want, but it's a little bit closer to doing what I want than what I had a minute ago. And many of what I've noticed in the past, especially with things like loops, many first-year students, the issue that they have isn't that they don't understand the techniques, it's that they have writer's block. They can't start the assignment because they're staring at a blank screen. If you know the assignment requires loops, even if you don't know how to write the loop it wants, write any loop. And then you have something. You've got something to play with. And maybe at that point you can make some modifications and get it closer and closer. And as you go, you can keep compiling and running to see how close you're getting. Okay, so I'll just space that out. We'll compile and run this to see if it does what I expect it to do. There we go. And then we'll run the code. Okay, so it prints 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I think, well, I don't want to start at the number 1. Okay, I'm trying to artfully scroll this so I can see both my expected output and my code on the same screen. I don't want to start at the number 1. I want to start at the number 6. And I don't want to move ahead in steps of 1, 1, 2, 3, 4, 5. I want to move ahead in steps of 6. 6 plus 6 is 12, plus 6 is 18, plus 6 is 24. So maybe we'll try that. Okay, so I'm going to start my counter at 6. At each step, I move my counter up by 6. I don't move it up by 1. Okay, so we'll save that. And I noticed, and I think, okay, so what's the problem here? Well, okay, I'm only seeing the number 6. Okay, that's not great. I mean, I guess I'm starting at 6. I'm a little bit of the way there, but it stops. And I might stare at this, and this is a classic loop debugging problem. Was the issue my initialization? Well, no, it looks like it is starting at 6. I don't know whether my incrementation is working correctly, but I go look at the second ingredient, my continuation condition, and I think, well, wait a minute. I want to go up to 60, not up to, just up to 10. Oh, whoops, and then it pastes in. I'm still figuring out why it pastes stuff in randomly like that. Okay, and so now it's saying there's 6, 12, 18, 24, 30. Okay, good. So I actually have all the multiples I want, but they're not all on the same line. And this is basically a debugging problem. It's weird to think of it that way, but the code isn't doing what I'm expecting. Is there a way I can fix the problem? Well, the problem in my mind is that there's too many new lines. I'm pressing enter too many times inside of my output. And I might remember that this thing, \n, is what is the equivalent of pressing enter. So let's just see what happens if I delete that. And you'll notice it doesn't give me quite what I want. Okay. So it looks like all the numbers are there. There's 6 at the beginning, and then after I see 12 and then 18, but they're all mashed together. And the reason is because I'm telling printf just to print out numbers. I never tell it to print out a space. So I think what I'll do is I'll have it print each number and then a space. Okay. And so we'll try running that. Okay, so it prints out 6, 12, 18, 24. That's looking good. It gets up to 48, 54, 60. That's looking good. But then this weird thing happens. And what you'll learn over the course is that what's happening here, if you see this is our command prompt. If you see this up against the same line as your program's output, it's because your program didn't print a \n at the end. And we like programs that end with a \n, and it's considered to be correct in the context of this course because we want the program, when it's done its output, to sort of clean everything up. And so what I should do, as a matter of good style, is when I'm done, I should print a \n all by itself. And that's equivalent to just saying press enter, and then that's it. In fact, I'm actually going to, even just to emphasize a point I'm going to make in a minute, I'll even print out the word done when I'm done. Now, the prompt actually says not to do that. It just says print out the multiples, but just to show what happens. So I'll try this again. I'll clear my display. There we go. And so we've got the first 10 multiples of 6 and then the word done, just to demonstrate that we've gotten all the way out of our loop. Okay, so that's our first problem, and that was just a vanilla loop exercise. There could be a question of this difficulty on a midterm, but typically midterm questions involving writing loops, which are almost, well, they're a month away from when I'm recording this. They're just under a month away from, or 3 weeks away, or whatever, from whenever you're watching. You might be watching this during the midterm. Okay, who knows when the midterm is? Hopefully you caught it in time, you didn't miss it. By the time we get to a midterm, loop exercises tend to be a bit more complicated than this one. So here's an example. Now I want to write actually I shouldn't even say write a loop. Write a program. Write a program that prints out this multiplication table. So it prints out the first 10 multiples of 10 different numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now hidden behind the question, there is the implicit assumption that you should be able to write a program that could print a table like this that had 1,000 lines. It prints the first 1,000 multiples of the numbers 1 through 1,000. The fact that we're only going up to 10 isn't really significant here, but it makes the problem a bit more manageable. Okay, so why am I juxtaposing these two problems? Why did we start with this? Well, because I wanted to emphasize that if you want to print out one line of the multiplication table, you would use a loop. And what I want now isn't just one line, I want 10 lines. But each line, if you think about it, printing out the multiples of 6 isn't too different than printing out the multiples of 5. In fact, why don't we adapt this program, or we'll do it over in the code for the new exercise. So I'm going to copy and paste this. I have one line of the table. And what I hope you will all do is when you get a problem like this, it's really easy to panic. You can say, okay, I have no idea how to do any of this. Are you sure? You don't know how to do all of it, but could you do any of it? You probably could. If you pick out something easy, for example, could you write the first row? Probably yes. Could you do the row number 6? Also probably yes. So it's not reasonable to say you can't do any of it, but it's tempting to panic and not want to do anything. So we know we can do one line of the table. This is how I would do the line for 6. And let's actually compile and run this just to prove that I copied and pasted correctly. So it's called multiplication table. Multiplication table. And we'll run that. And there it is. So it just gives us the line with the 6. And though I think to myself, okay, so what do I need to do to get more than one line out of this? And as a cosmetic change, I'm going to move it like this. So I make a variable called counter, which tells me which column I'm in. So 6 times 1, 6 times 2, 6 times 3. And then I started at 6, and I keep going until I get to 60. And actually, we could write this out a different way. 6 times 10. I want to start at, in fact, I want to start at 6 times 1 and keep going until I get to 6 times 10. And at each step, I add 6. Okay, I'm going to jam these lines together, and I'm going to remove this nice informational comment from a minute ago, and we'll see what happens if I run this just to make sure everything looks good. And the question is, how do I get the table to, let's say, the line for 7? Well, it looks to me like what I would do is I would write the same loop. I would just start at 7 times 1, go up to 7 times 10, and add 7 at each step. Okay, so let's try that. I'm actually going to copy and paste. Okay, so counter equals 7 times 1. Counter goes up to 7 times 10. Counter equals counter plus 7. Looks like that's the valid row for 7. I want to maybe sidetrack a bit here and talk about a philosophical question. So suppose I have a while loop, and it doesn't matter what the while loop is for this, so while counter is less than 10. I've got some stuff in the loop body. We've seen that we can put various types of code in the loop body. So, you know, I can print something out. I can do arithmetic, counter plus equals 1. Maybe we should ask the question, what am I allowed to put in here? Inside of a loop body, what am I allowed to put? And I'll answer that. The answer is you can put any code inside the loop body. Any code. You could have it be 100 lines, you could have it be 1 line, but you can put any code inside that loop body. Okay, next philosophical question. Is a while loop code? I think the answer is yes. A while loop, a print statement, adding a 1 to a number, all of those are code. We've been learning code. This is a course on learning code. If a while loop is code, and you can put any code you want inside a while loop, what's stopping you from putting a while loop inside of another while loop? So chew on that for a minute. Pause the video if you need to while you chew on that. Let's keep moving on this problem we had above, the multiplication table. So I've got the row for 6, I've got the row for 7. Can I do the row for 8? I think I can. I think I can copy and paste. And remember, that's my recommendation for designing loops is get to a point where you can copy and paste. And I noticed that when I copy and paste, I only change 3 things. I change where I start, something times 1. I change this, something times 10. And I change this, plus something. And it's the same something all 3 times. And I copy in that \n to make sure that each row ends. An exercise you can do on your own is see what happens if you forgot this. It would be ugly, but it wouldn't be the end of the world. And now I have the row for 8. But this isn't really helping. I don't want to copy and paste the whole table. I want to find a way of automating it, because what if the question was not 1 through 10? What if it was 1 through 100? And I stare at this for a minute and I think maybe I can automate some of this. So really, if I want to print the row for 6, it's row number 6, and I do 6 times 1, 6, and I go up to 6 times 10, and I add 6 at each step. So I'm going to make a new variable, row number. And I'm going to set here, row number equals 6. And then at each step I say, okay, so I want to set the counter to be row number times 1. I want to go up to row number times 10. And to my counter I add row number at each step. And so we'll make sure that that works. So notice that what I've done here is I've peeled away that 6 from this inside bit, and I've just used one variable to stand in for it. And you might notice that will make it easier for me to copy and paste. And remember, when copying and pasting gets really easy, then you can wrap everything up inside of a loop. So I still have that. I'm going to redo my copying and pasting from earlier here. I'll just do the row for number 7. Row number equals 7. And I leave all of the other code the same. And you'll notice I still get the row for 6 and I still get the row for 7. Okay, so here's the next leap. If row number equals 6 and I want the next row to be 6 plus 1, isn't it reasonable to do something like this? Row number equals row number plus 1. So I've just finished with row number 6, and maybe I'll even move where I do the incrementation. Maybe that'll look a bit more familiar. I've just written out row number 6, and I want to set up for the next row in the sequence. That's row number 7. Okay, so we'll try that, and we'll run this code. It still gives me the row for 7, and maybe you could convince yourself that once I have this block here, all I have to do is copy and paste it over and over again. So there's a few times. And I can now print out rows of the multiplication table, 6, 7, 8, 9, no big deal. So what I have is exactly what we've seen in earlier exercises on loops. I have exactly what I need to turn this thing into a loop. This whole huge ugly thing can be turned into a loop body now. And this looks a lot like initialization, somewhere to start. So I'll try that. I'll grit my teeth and cross my fingers and hope that this works. So I'm going to start with row number 1. And I'm going to keep going until I get to row number 10. Well, row number is less than or equal to 10. And what I want to repeat is everything between this line and this one. Because we already saw, as I've mentioned before, if you can just copy and paste the code, then you can stick it inside a while loop body. Now, I've mentioned that I like indenting code to make it clear what it's inside of. If you select a whole block of code in Jupyter Hub like this and press tab on the whole thing, it'll indent everything for you in one pass. So you can see I just did that. You might notice by now that the indentation really does help. It makes it way more obvious where the loop begins and where the loop ends. If it was all up against the left-hand side, it wouldn't be very obvious. Okay, so we'll try that. You're staring at this. You might have had to pause the video and take a break by now. I don't blame you. You're staring at this and thinking, okay, this is getting a bit excessive. It was already excessive. I don't know what we call it after it gets, after we get to excessive. What's the next stage called? But there it is. It runs. It gives me what I want. The spacing is a little bit off. I'll talk about that in a minute, but it gives me my multiplication table. And if you think about this a bit, you might notice if I wanted to go up to 100 rows, I could do that. I just modify the continuation condition of what I'm going to call the outer loop. So what we have here is a while loop. Inside the while loop is a loop body. Every time this question comes back with the answer yes, I execute everything inside the loop body. Of course, inside the loop body, I run into this other loop. And for as long as this question comes back with the answer yes, I roll around inside of this while loop. And when this while loop ends, I go down to the printf, I increment the row number, I hit this, which means I go back up to the top, and I ask the question in the outer loop again. I'm allowed to put any code I want inside of a while loop, and that includes another loop. So what we have here is an example of what is called nested loops. That's pretty ugly. In the 4 days, I have not spent any time practicing my on-screen handwriting. I really should have done that. We have an example of what is called nested loops. So that's where you put one loop inside of another. And as I mentioned earlier, this is terrifying. I don't blame you. But there is a sort of sublime beauty to it. This thought that what can I put inside a loop? Any code. Is a loop code? Of course it is. There are no special rules. Anything counts as code. You can put anything inside of a loop. And that's nice. It's nice that C has such consistent rules. It's true that it's terrifying because of all of the different options this suddenly opens up in front of us. But it's sort of reassuring as well. There's no special rule to learn about what kind of thing can I put between lines 31 and 39 in here. No, I can just put any code I want. So this is an example of a problem that can be solved with nested loops. And one of the Thursday examples I'm going to do will be talking about how to design these solutions from the ground up. Generally, if you get a problem that looks like it needs nested loops, this is a pretty classic example, what you should do is focus on, can I do one row of the table? So design it from the inside out. First design that inside loop, which is one row of the table, and see how you can repeat that to generate every row of the table. So one last point to make, you might notice the spacing here looks pretty disgusting. So it sort of has this weird staircase effect because on the first row, everything is only 1 digit long. On the second row, it jumps up to 2 digits, sort of halfway through. The table given here looks really nice. And what's really happening is we've arranged for every number to take up exactly 3 positions. So there's spaces if the number is only 1 digit long, but if the number is 3 digits long, it takes up all 3 of them. And that makes a nice alignment effect. There's a way of doing this. You're not tested on this. This is, of course, completely irrelevant to the course. It's just a matter of making the output look nice. If you ever get a co-op where you have to write code, you will discover that your manager always has weird expectations of how the output looks, and therefore it's good to, learn tricks like this, but you're not tested on it in this course. We'll use it every now and then. We'll just tell you which one we recommend. So if you want to make a number take up a specific number of spaces, what you can do with %d is you can do %3d. That says print every number, but use three positions to print each thing. If the number's not 3 digits long, add some spaces at the beginning. So again, not tested on that, but an interesting trick to know about. And there we go. And now I get the table nicely formatted with the aid of 2 loops, one inside the other. So an exercise to do, first we'll talk about this one again in a Thursday, so one of these variations, but also you might want to try writing this one from scratch. Give it a while. Don't look at this solution. See if you can write it from scratch. It will probably not be your favorite thing to do. It's one of those things where if you practice doing this, you will begin to figure out how your brain can easily wrap around problems like this and what works for you in terms of how to deconstruct it. You're given something complicated, something that's a bit monolithic. How do I go from having nothing to having this whole thing? And it's a good skill to learn, okay, how do I hack away at this? How can I go from having nothing to doing one simple thing? How can I go from doing one simple thing to doing one maybe more complicated thing? And now how can I generalize that to do what the problem is actually asking?